The following video is a guide to the concept of power and how we can calculate the power of an event when we're given the energy transferred and the time taken for that event. So we're going to look at these four different options. Which one do you think is the most powerful? So let's start with the equation. Power is equal to energy divided by time. That is the energy transferred divided by the time taken for that energy transfer. Remembering that power is measured in watts, energy is measured in joules, and time is measured in seconds. So let's take a look at our first problem. A light bulb is left on for 30 minutes. In this time, 108 kilojoules is transferred electrically to the bulb. Calculate the power of the bulb. So the first thing we need to do here is make a couple of conversions. We don't want minutes, we don't want kilojoules, we want seconds, and we want joules. So let's start off with the easier one. We know that 1 kilojoule is 1000 joules, and so therefore 108 kilojoules is 108,000 joules. Next, we know that there's 60 seconds in 1 minute, so what we need to do, since we have 30 minutes, is multiply 30 by 60 to give us 1,800 seconds. Once we've done that, we simply plug in the numbers. We have P equals E over T, replace those, and we have power equals 60 watts. Now you'll notice I put 60 watts rather than 60.0. That is because I want to give my answer to two significant figures. Because even though in the question we have one number with three significant figures, the other number is only 2, and so therefore we can only be confident in our answer to two significant figures. Next, a piano falls down a flight of stairs. In this fall, 5.4 kilojoules of energy is transferred from the gravitational potential energy store into the kinetic energy store of the piano. It takes 0.8 seconds to reach the bottom of the stairs. Calculate the average power of this transfer. Now the reason it says average power is because in reality the piano is going to bump and hit the stairs, and so the power will not be constant throughout the entire fall. Sometimes the power will be greater, sometimes the power will be less, but we're looking at the power transferred over the entire 0.8 seconds. So firstly we do our conversion. 1 kilojoule is 1000 joules, so 5.4 kilojoules is 5400 joules. We then write down our equation, plug in the numbers, and that gives us 6750 watts. Now, since we've only got two significant figures in the question, we're going to say that this is approximately equal to 6.8 kilowatts. Next, a bow at full stretch transfers 50 joules of energy from its elastic potential energy store into the kinetic energy store of the arrow in 0.02 seconds. Calculate the power. Again, we write our equation, we replace the numbers, and that gives us 2500 watts. Finally, a weightlifter lifts 2000 Newton weight a distance of 1 meter from its original position. He does this in 0.8 seconds. Calculate the power output of the man. Now in this case, we haven't been given an energy. We've been given a weight and a distance, or a force and a distance. And so we should remember that work done equals force times distance. That means it's 2000 newtons times by 1 meter, and that gives us a total work done by the man of 2000 joules. In which case, the power output, P equals E over T, we're going to take our 2000 joules from our work done, divide it by 0.8 seconds, and we find that the power output of that man is 2500 watts. So, the most powerful energy transfer taking place in all of these was the piano falling down the stairs at 6.8 kilowatts, significantly greater than all the others.